Welcome to this debrief video where we'll look at the 3 section B questions in the 2025 December performance management mock. I would generally allocate 54 minutes to the section B, but there are 3 case studies, so that's about 18 minutes each. Anyone who's watched my section B stuff before know I'm quite a fan of seeking out what I call the section B outliers. Each section B case study, the stem of the question if you like, then has 5 questions, but almost always there's at least one that doesn't rely on this information. They're generally a bit easier to get the marks and a bit quicker. So what I tend to do is look at the 5 questions, trying to identify those outliers, and I answer those first. Then I come back and I read the scenario, and I only then have to answer the remaining questions. The other reason for reading through first is it means when I come back to reading the stem of the question here, my brain is already searching for things that might help me get to the answer. So let's take a look through and we'll follow that process. Well, this is a calculation, so that definitely will rely on the information on the left. Non-calculations are generally a higher chance of being an outlier. This one indicate by clicking on the relevant boxes below whether each of the following statements is correct or incorrect if the learning rate for GHCO is 80%. Now, although this is about GHCO, this is very likely an outlier because it's given us all the information here. So with a learning rate of 80%, is it correct that the cumulative average labour time for 7 batches of output will be 80% of that for 6 batches of output? This is incorrect. An 80% learning rate occurs when we double the output, i.e. going from 6 batches to 12 batches, you double the output, then the cumulative average time will be 80% of the previous average time. So that one's incorrect. The same learning rate will continuously appear and be applied throughout all levels of cumulative output. That's not true. At some point in time, it's expected they'll reach the steady state where no more improvement can be made, and so therefore the learning rate will no longer apply. So that's one outlier. Which 2 of the following initiatives are not likely to lead to an increase in the learning curve effect? Again, this looks like an outlier to me. The management are exploring several measures to further improve labour efficiency, which 2 will not. Implementing a short-term employment contract for all staff, well, that's not going to improve the learning curve. The learning curve relies on a stable workforce. If you have short-term employment, you're more likely to have staff turnover. Providing on-site training to all newly recruited staff, training is one of the ways to improve the learning curve effect. Changing from a time-based remuneration to a piecework remuneration, that is likely to help because they're motivated to produce products, so that will help the learning curve, so it must be this one. Implementing a staff incentive scheme that's based on the balanced scorecard approach. So learning curve effect is about how quickly they can produce products, whereas the balanced scorecard looks at a wider range in performance, and therefore might actually distract from that focus on producing products. This is a calculation, so that's not an outlier. And this question, based on the current pricing approach, which of the following is most likely if a new order has a price quoted based on an estimated learning rate of 90%, but the actual learning rate is 82%. So this is an outlier. We're just being asked, what are the impacts of getting the learning rate estimate incorrect? So let's walk through the steps of what happens if instead of it being 90%, the learning rate is 82%. When they actually come to production, the improvement in the rate of production will be faster than they estimated. If it's faster than they estimated, that means they'll need fewer hours and therefore it's more profitable. So we can eliminate answers 2 and 4. However, they would have quoted based on the 90%, so that would be less competitive. So the correct answer is this one. So as you can see in this first section B question, out of the 5 questions for GHCO, 3 were outliers. So I've now just got 2 which are linked to the narrative given on the left. So as with the section A videos, if you pause now to read through this, and we'll do this implied learning rate to the nearest whole percentage calculation next. To work out the learning rate from a set of cumulative hours, we need to remember when we double batches, so we go from 1 to 2 or 2 to 4 and then 4 to 8, the cumulative time will reduce by a fixed percentage, and that percentage is the learning rate. I've set up a little table here. I've just copied this top two lines from here. So now the cumulative average per batch is the next line, which is 8 divided by 1 for this one, and 15.2 divided by 2 for the second batch, which is 7.6. So therefore the learning rate is 7.6 over 8, which is 0.95 or 95%. Although you wouldn't need to do this if we were to use 4 batches, that's 7.2. So 7.2 divided by 7.6 should in theory give us the same answer. A little bit of a rounding error, but it is still 95%. So 95% is our answer there. And then the other calculation was this question 19, and we're asked what's the price to be quoted per unit for the order of 150 units. So the costs are the direct materials of 150, the labour costs, which we've got 12 per hour, I'll come back to that, fixed overheads is 70, and then the markup is 25% on top of whatever's the total above. They come to 220. If I had 25% on, I'm probably not far off this anyway, so I can probably eliminate this. But now I need to work out what is my labour cost. This is probably the bit that most people found tricky. 150 units, and there's 30 in a batch, so we're making 5 batches. The average time is actually given to us as 35.50. So the total labour cost is $12 an hour times 35.50. That's for all units, then we divide that by 150. So our labour is actually 284. And we add in the 150 and the 70, we've got 504. And I multiply by 1.25 to include the markup, and I've got 630. And that's that section B question complete.